Well, good evening, good morning, good day to everyone there. We see a lot of familiar faces around. Well, here with us, we have Wojtek Simetka. He's the Storage and Communications PO for REEF. Well, the importance of having or of making this webinar, it was about, well, first of all, last week on Consensus, we announced a new service by the RIF team, especially deployed and developed by Wojtek, that it's the RIF publications feature. And we wanted to go a little bit deeper on that point. And also we wanted to know about, well, what exactly makes storage, what is behind the communication system. As before we've seen on another webinars like the RIF introduction, one made by Alejandro Narancio, and the RIF Lumino. We will go on that line and also talk a little bit about, well, the importance of having these centralized services like storage and communications. So just a friendly reminder, this webinar is being recorded, so if anybody needs to get out, they can see it afterwards on our YouTube channel. I will share the link on the chat box for later. So, and also if you want to make any questions, you can do it also on the chat box or ask it personally to each of us on the feature that says questions. So it's pretty easy. We will try to make a very easy and going dynamic. So thank you so much for being a part of our weekly webinars. And well, I leave it to you, Wojtek, now. So I'll say goodbye, but I'll be on the backstage.
Thank you very much, Fran. Thank you for struggling with my name, but for the really good introduction. Hello, everyone. This is a little bit unusual for me because even though I do most of my work just online, I still, when I go on stage and when I present something, I actually have an interaction with people. So I would appreciate if we can mimic this as much as possible. So whenever you have questions or some remarks, please don't hesitate to write it in the chat or in the questions, and I will try and monitor it throughout the whole talk so that we can have a little bit more of an interaction and it's not just me saying a monologue. So without further ado, let me just share my... Okay, wonderful. Please someone complain if it doesn't work. So decentralized storage and communications, and why do we need them? So I actually originally didn't want it to ask this question, or at least have it in the name of this webinar, because I didn't want it to feel like I'm some sort of anarchist. I'm someone who's like against the system, pushing for a decentralization, which I am, arguably, but not to this extent. And I also didn't want you to take decentralized storage as such technology, as technology that is against the system, because I do think that storage and communications and decentralized storage and communications is something that we all need. And we need it in this form, not in the form that it currently is available for some of the use cases, right? So why do we need decentralized storage and communications? Any useful applications at some point will need to store and retrieve data. In the past, we used to save most of it on our computers or on our phones locally. But later we started to move towards cloud storage. And this fits very well with the client-server architecture of the applications. But it brought a number of new risks and challenges. Some of them are centralization. The internet was supposed to be a distributed system where each node is expandable. That's how it was actually even designed. However, nowadays, the majority of our data is concentrated in centralized hubs like Facebook, Google, or Microsoft, which increases the risk of the data abuse, leaks, and denial of service. so you cannot actually access your own content. Another problem is censorship, where web resources like web pages can be easily censored by blocking or attacking the servers where the content is stored. However, if we store this content on a decentralized storage, it is much more difficult to censor because it is somewhere in the decentralized network, but you don't really know where. Or that's one of the ways how it can work. Another issue is data loss and deplatforming, where a provider can either stop existing or you maybe are no longer profitable for them. So they just decide to erase you and you lose all your data. The issue of the current infrastructure as well is scaling and latency, where if content is popular, let's say you are a very famous streamer or your YouTube videos are really good, to ensure that it runs, you cannot just host it on one computer. You actually need to get this content closer to your to the people that consume it, and this is something what we often use called content distribution network, where essentially you replicate the same video, and instead of serving it from just one central server, you actually purchase the servers all around the world. But this is expensive. This is something that only bigger projects can afford. And if you are a small project but you have a success early, this can actually hurt you. So we're also trying to tackle that with decentralized storage. Then connected to that, and especially in the communication, we have a problem of espionage, of people spying on you or listening to your conversation. The whole issue of like a revenue creation, where essentially right now you pretty much just have to support some or purchase some storage and communications from some services. The others are not as viable for you. So all of that is something we want to kind of touch on with decentralized storage and communications. So let me start a little bit with showing you what Rift storage is, but I promise I will more focus on how it works rather than trying to show how we're approaching it. But Rift storage is a unified protocol for decentralized storage solution. It has, the goal is to actually answer pretty much all the problems from previous. So it has to be censorship resistant. It has to be permissionless. So anybody from anywhere can access their own data. It has to be anonymous. So nobody can actually know who you are when you are downloading your data or uploading them. It has to be fault tolerant. So if some nodes in the network fail, you should still be able to retrieve your data. And the last one, which is arguably the most challenging, it has to be self-sustaining. So there has to be a economical motivation for you to be able to upload the data, but also for the network to sustain and get basically everyone who provides their storage or some sort of bandwidth to actually get revenue out of this and have economical motivation. So this all fits into much bigger part, and I think you've seen in some previous seminars everything about RIF and RSK, but essentially the idea is you have Bitcoin as a store of value, then RSK as the open finance and smart contract layer, and then you have the RIF services and other services which make it easier for you to build the decentralized platforms, decentralized applications. Okay, decentralized storage. So I will show you some of the steps of what you actually need to do in order to upload file to decentralized storage and then to download it, right? So this process, basically, we can split it into, let's say, 3 categories. One of them is file preparation, then uploading, downloading, and again, some sort of file preparation before it's served to the end user. So I'm going to take as an example this beautiful picture of Lena, which is very often used in a computer vision presentations. And that's what I'm actually going to do, visually show you how you prepare this file, how do you distribute it in the network, and how do you then get it from the network, right? So let's say we have this file, and the first part is to actually split this file into chunks. And let me actually hide this. And splitting a file into into chunks is, of course, not as visual as here, but basically you just take the file and you, let's say it has 4 megabytes, and you just cut it to 4 kilobytes. So you just create 1024 4 kilobytes chunks, right? But not always your file is exactly 4 kilobytes. So you actually need to pad it. So you actually need to add some white data. And then optionally, you can, of course, encrypt your data with some key to encrypt these chunks and make sure that here it's more like a visual scrambling, but in reality, this would be completely undecodable. You could not actually read someone's data when they are encrypted unless you know their key. Okay, and then you construct something called Merkle tree, and here we have somewhat of a balanced tree. And essentially the way it works is in the leaves at the bottom, you have all the individual pieces of the data. You calculate some sort of hash on top of them to ensure their consistency, but also as a pointer. So you can always verify when you download this data that the content hash, you can recalculate it again and you can compare it. This is a technology that has been used for thousands of years to well, not thousands, but for several decades, even to distribute Linux distributions, for example. So you calculate these hashes, then you create another, let's say, another hashes of those hashes, and you construct this sort of tree. And then the root hash all the way at the top is something that we call file descriptor in decentralized storage. So this is a unique identifier through which you can actually download the data. And we already have one question, so I'm just going to quickly answer it. Are there utilities and or libraries to do the preparation? So there is a number of utilities. None actually comes to my mind, but I know they exist. But usually this sort of preparation of file is done through some decentralized storage solution. And that's, for example, Swarm or IPFS or BitTorrent or anything like that. So I'm just describing what these softwares usually do, but usually this is very transparent to the end user. They don't actually know that all of this is happening. All they care is that they uploaded their file. So we're looking very low level at what is actually happening with your files. Okay, so this balance tree is usually used, but if you wanted to, for example, do a video streaming, you can construct a different tree, which of course will have some sort of different pointers. But for example, here, if you had a video, it would be very easy for you to jump let's say 30 seconds in the video. So let's say here is where 30 seconds start. You can just very easily get the root hash. Then you just get one of the hashes, and then you're directly already here. So that's super useful for video streaming, for example. Okay, so now we have we basically have the file prepared. So let's have a look at how you can upload it and download it. And I'm going to show you how this is done in two of the most used systems, I would say, or most interesting. One is IPFS and the second one is Swarm. So let's start with uploading, and let's start with IPFS network. So IPFS network essentially works very similarly to how torrents work in a principle. So essentially, you have a set of nodes, which are different computers that are running the IPFS software, and they are connected together in some fashion, right? And when you want to store a file, all you need to do is you actually upload this file into your own computer, into a specific folder, or use some sort of user interface, but essentially just takes this file, stores it in the folder. Maybe it encrypts it, maybe it also splits it into the chunk, it usually does, and constructs this Merkle tree. But for all purposes, it's basically stored on your local disk, and you can always retrieve it. Now, if somebody else wants to get this file from the network, let's say here it's a node C, it essentially needs to find who stores this file, right? And in torrents, for example, you have all sorts of trackers for this. In IPFS, you have something called the DHT, distributed hash table, in which you can just look up who is the storer and download the file directly from them. So you connect to them, make the request, and download the file. There is all sorts of magic of how you actually look up in this distributed hash table, but I don't want to go that much in detail unless there is an interest later on. But somehow you basically find out who is the storer, and you just directly download it. Okay, so now essentially you have two copies of the files in the network. So node B and node C is storing it, and you actually have this in the DHT. So let's say we want to download it from the node 2. All they do is they actually contact B or C, or actually both of them at the same time, and they download some pieces of the file, some chunks from node B, some files from node C, depending on the speed. And as the file gets more and more popular in the network, it replicates and your download is faster. In torrent, you would call those people who have the files seeders, and then those who download would probably be called leechers, or only if they don't provide it back. Okay, so in IPFS, downloading a file, essentially there is no payment, but there is some sort of a system similar to BitTorrent, where you actually used to have something called tit for tat. So you could only download content as long as you were providing similar value to the network. So that made sure, otherwise you were disconnected. So that made sure that you couldn't always just download the content. At some point, you actually also had to provide some to the network. There were all sorts of things how to go around it, but this is the basic premise, and I think this actually almost deserves a Nobel Prize in economy, because this is a very nice incentives model. How can you ensure that you have a fair use of resources in the network? In IPFS, they have something called BitSwap, which works similarly, right? But another issue that you maybe have discovered is, how do you ensure that the file you upload is available in the network, even though you go down, your node goes down. And this files are only available as long as somebody is storing it. That's the answer. But how do you prove that someone is storing that file? And how do you actually make sure, or I don't know, or pay to this someone? That's something that IPFS itself is not solving, but the extension of IPFS called Filecoin is solving, and that's also out of the scope of this webinar, let's say. But I'm also happy to answer some questions there. Okay, so how is this done in Swarm? In Swarm, the network layout is a little bit different than in IPFS. You have something called Kademlia. So IPFS also uses Kademlia, but not for, let's say, downloading the files. But here in Swarm Network, you only have Kademlia. And essentially, Kademlia topology means that you, let's say you are a node 0, you are connected to nodes that have address that is closest to your address, right? So you're connected to those nodes, and then maybe to some that are a little bit further away, and then one or two or few that are like very far away, right? And this is, for example, similar to how routing in normal internet works. And so you also have some sort of locality, and based on IP, you can actually kind of guess where the people's computers are. But here it's very useful, because when you want to upload a file, you don't actually store the file yourself, but you upload it to the network. So all these chunks, let's say you're the node F and you're trying to upload the root hash, right? The first chunk of the file. And it starts with 3. So our proximity here would be the prefix of the hash. So here, when it starts with 3, you're the node F. So the closest to 3 of all your peers, of all your nodes you're connected to, is node 2. So you send it to node 2, and then, because this is forwarding Kademlia, this node 2 on your behalf actually forwards the file to node 3, who eventually stores it, right? And same goes for this file, which actually there is no node with prefix 1, which in normal network probably wouldn't happen, but in our small network it happens. So it's actually maybe stored on both of these nodes. In reality, those are usually some sort of neighborhoods. So each chunk or each piece of a file is usually stored on more than one computer. So even if several computers go down, your file still exists. Okay, so all these files get basically stored here on node 0, 2, and 3. And now, how do you retrieve this file? So let's say you're a node D now, and you want to download this file. So you ask your node, okay, can you download this file for me? So what this node does, it says, okay, 3 starts with 3. So the closest peer I'm connected to is F. Then, so you ask F, do you have this piece of the file? F says, no, I don't, or it doesn't communicate yet, but it says, okay, I don't have this file, but maybe 2 has this file, 2 also doesn't have this file, 3 has the file, and that is how you retrieve the file. So your request is, again, forwarded through the network until you basically retrieve it. And similarly for the rest of the files, file pieces, until you get the whole file, and then you again reassemble, right? Okay, but how do you sustain this network? Why would anyone want to participate in the network? You can do that by something we call swap protocol. So a swap protocol is also a modification of a tit-for-tat algorithm. So with each of your peers, you basically calculate, you keep a balance of how many data you downloaded versus how many data you provided. And if this balance reaches some threshold, so let's say here it's 50, you actually settle with a payment. And this payment can be some on-chain network. So in our Riff Swarm network, you actually pay with Riff on top of the RSK, and you can settle a small with a small money for any imbalance, because in reality there will usually be a number of nodes that are mostly downloading and a number of nodes that are mostly storing. So those that are mostly storing will probably want to be paid for this storing, and when you are downloading, it means you're requesting the content. So you need to probably pay for it. So that's a downloading file. However, we also need some sort of incentives for uploading the file. You cannot just upload a file, or uploading cannot be free, because that's one form of an attack. You could essentially spam the whole network and make it unusable. So for that, we created something called postage stamps, and it works very similar to how postage stamps work in the normal mail. So you buy this postage stamp from a smart contract. You usually buy a lot of them, and then you put these stamps on top of your chunks of data, and that's basically proves that you paid for this data, and it can pass through the network all the way to the node that is supposed to store it. For persistence, for ensuring that your files exist there, there is a concept of swear and swindle, which is also kind of outside of the scope. But in a short term, what we're doing and what we're going to release as a service is something called Riff Marketplace Persistence. So you can actually pay someone directly to ensure that your files exist in the network. And it's a system called global pinning that Marcelo and Santiago from our team are working on, and soon this will be released for you. Okay, so now that we have decentralized storage kind of walked through a little bit how it works, let's have a look at decentralized communication. So what do you want to do in communications? You usually probably want to send a message, and you want to send a message to one person or to a group. And one thing that you have to ensure is that usually you want this message to be received even if the recipient is not online, right? So we can actually use the same network for storage, and that's something that's an insight that together with the Swarm team we made, and that is that storage comes before communications. So you kind of need a storage network for a communications system to fully work. So similar to how you would use the storage kind of network for files, you can actually use it for messages, because actually every message is in reality a file, right? You can store it as a file and it has some content hash. So every message is a file. So you can use a storage network for that. And actually you can somehow a little bit cheat and manipulate where this message will be stored, where this file will be stored. So let's say you have some sort of fixed content, right? So here it's Hello Montevideo, and then you can add some separator, and you can start adding random characters and modifying the content hash of this message, of this file. So when you do that, you can kind of construct your own hash, and you can make sure that you can send it. Let's say here it's F3. So let's say we wanted to send it here from the node 0 to the node F, or maybe from the node 2 to the node F. We could actually just keep adding characters to our message until the content hash falls within the neighborhood of the node F. Okay, so to sum up, current challenges: centralization, censorship, data loss, scaling latency, espionage, revenue models, sustainable revenue models, and efficiency on the network. That's all we need to kind of find a solution for. And that's what we are trying to do with storage, decentralized storage and decentralized communications, and build an infrastructure that anyone can use for their own solutions, right? So that's Rift storage, Rift communications in this case. However, we kind of knew that we don't want to only stop on building the infrastructure, or we wanted to make sure that our protocol is actually easy to use. So we decided that the best way would be to build our own product and understand how users want to utilize our infrastructure, right? And there is a number of use cases where decentralized storage can add significant value. And one that stood out to us is a content creation industry. And currently it faces three main issues. The first one is how to sustain the operation of your studio, the problem of fake news, and the problem of censorship and deplatforming. And since we have some close ties with Latin America and the problems it faces, we decided to focus on the last problem, and that's censorship. And we have created a new product called RevPublish. So let's have a look on how it works. And I'm going to play some recorded demo right now. And I hope it works. But if it doesn't, please let me know. RevPublish is a tool that makes it very easy to upload text-based content like blog or newspaper articles and consume it in decentralized fashion. Our goal was to seamlessly integrate into any workflow you might already have. So as a content creator, all you need to do is open the soon available RevPublish website, drag and drop your content, and click upload. This works best for static websites or PDFs. Here you can see me uploading our first article about RevPublish. If you are using WordPress, we make it even simpler. Just install the RevPublish WordPress plugin, and now each time you want to publish an article, you can choose to also upload it to decentralized storage. For example, we can see how CoinDesk could make their latest Bitcoin halving article truly decentralized. In both cases, behind the scenes, the system uploads the content to IPFS and gives you an URL which you can share, or just click this convenient tweet button. On the WordPress plugin, this information can also be found underneath each of your articles. Our main focus, though, has been on how is such content consumed. The process has to be incredibly simple and work out of the box. That is why reading an article shared through RevPublish is as easy as clicking on a link. It opens in the browser and after a short while shows the article. In this way, the piece gets to you through centralized gateway. However, if you wish to be anonymous or you cannot access the gateway, all you need to do is install a browser extension. Here, I have an IPFS companion installed. So my browser, instead of using the centralized gateway, directly uses the IPFS. Nobody can stop you now and prevent you from reading about blockchain, decentralization, or any other, in some areas blocked, topics. Okay, wonderful. So we are currently working with a number of influencers and newspapers to make sure RevPublish meet their needs. And we have a few features we want to finish before opening it to the public, like integration of RNS, so that articles can have some memorable names. We want to improve also the management of the stories. For the Swarm site, we are excited to continue with our collaboration and with our partnership. Soon we will bring you a feature which makes it possible for you to guarantee that this content that you care about is downloadable, even if it normally wouldn't. So that's the global pinning feature I've been introducing earlier. We are even more excited to continue this collaboration, especially since now we're a unified team that is tackling some project that is called B, which is the next evolution of the Swarm, and more information will be basically shared very soon. And we are, of course, also ensuring that our storage service works seamlessly with the other Riv services. So starting with the Riv Marketplace, where we soon will add the persistence side of storage. So you can pay to ensure that your files are always available in the storage network, even though you don't actually host them yourself. So that's an equivalent of purchasing a Dropbox space and just uploading your data there, but in a decentralized and much more, let's say, well, and more secure way, in a sense where you have a control over your data. And we also want to make sure that we support all the other initiatives and projects in Riv, like Riv on Chain, single sign-on system, decentralized identity, and the RNS, which all will need or already need a decentralized storage solution. And that's it from me. So I'm now here open for any questions you might have. And thank you so much for listening to my monologue. Fran, do we have any questions?
Okay, hi, coming back here. So for what I have, see much questions right here. Well, Jay asked one, are there utilities and or libraries to do the preparation? You answered it during the webinar, but maybe you could refresh that. I also shared some links in order to people to get into and learn a little bit. And as I mentioned also on the chat, we will afterwards, when we upload it, all of this to YouTube and to our webinars landing page, you will have the presentation ready to download. So if anybody has a question, now would be the time. Gabriel, the Riff strategist, he's leading the whole team of all the services that Riff is creating, providing, and announcing. If you want to add something.
Yeah, maybe we can
could
even
chat. We can invite him on stage.
We can even
I think he's following.
Invite him on stage. Yeah, sure.
I think he's on his cell phone right now, so he cannot talk, but he can write. Maybe he can send a message that's not just an emoji.
Wonderful.
Also here, well, we also have Manuel Ferrari from Money on Chain. It's a great DeFi project.
Yes, and actually, Manuel, I would very much like to brainstorm with you and understand a little bit better how we can bring money on chain on decentralized storage, so that your users are sure that the app they're using is verified and basically it works even if, let's say, your money on chain website is blocked. So for example, I can imagine that in Venezuela, maybe these crypto projects could get blocked, but with decentralized storage, you could actually bypass this restriction.
Okay, well, Gaku, he's saying that he's very proud of all of this. Yes, I think it was amazing. For the people who had a chance to watch it in Consensus last week, it was a very short presentation, just 10 minutes. So in this one, we could see a little bit more in depth, and also with the video. Well, Julian also, he's saying congratulations. With the video and everything, that you can also will be able to watch it in YouTube. I think that it was great. And well, whenever people or you or the assistants or somebody wants to watch it again, they can do it. So there's nothing else, I think, for now. Wojtek, thank you so much again. And for everyone who wants to also keep on watching and learning from our technology and our video and our webinars, you can also subscribe to the landing page I'm sending to the chat box where you can download the calendar and register to all of our upcoming webinars. Next week, we will have Gabriel talking at 5 p.m. Buenos Aires time on another great event that it's called BlockConf, and everybody is invited to join. I'll write here. It's also a free event. I'll share with you the link. So, well, also Mauro Coronel from Colombia. Okay, that's it for me.
Okay. Thank you again for being great, audience. You were very silent. I didn't even know you were there. But thank you for listening. And if you have any questions, you can always reach out to me or directly through iovlabs.org.
Exactly. And also remember that on the developers landing page, we have a chat open the 24 hours, and you can also write us on Gitter. So, okay, that's it. Bye-bye. Thanks.
Bye.
And we'll see you on Monday.